In the previous video, we looked at how an understanding of division is first formed. Here, we see how this understanding develops into children becoming fluent in early written calculation. Notice how arrays are used to show the importance of the order of numbers in division. That 2 divided by 8 isn't the same as 8 divided by 2. Later, the Singapore bars used to demonstrate the same point. That I find this value by doing 20 divided by 4, but I find this value by doing 20 times 4. Children perform divisions by counting up in the divisor using a number line. Steps will soon become increasingly more efficient, working up to steps being in multiples of 10. Here, children have to be able to partition numbers in different ways. If I'm doing 84 divided by 4, I'll need to partition the 84 into 80 and 4. Whereas if I'm doing 84 divided by 7, I'll need to partition the 84 into 70 and 14, multiples of 7. Manipulatives are used to introduce short division. Here, showing 78 in tens and ones. I can understand that sharing 7 tens by 6 means 1 10 and 1 as a remainder. Now I'm left with 18. 18 divided by 6 is 3, with no remainder. Let's have a look at another example, 620 by 3. Children probably find the first part of this question straightforward. How many 3's in 6? There are 2. How many 3's in 2? There are none, so carry the 2. Now this part can become more difficult. How many 3's in 20? Well, I can't use an inverse multiplication fact, so I might need Numicon to help me. I'll lay out 20 blocks, start adding 3's and see how many 3's fit into 20. I'll realise that there's 6 with a remainder of 2. So the procedure for short division looks a little bit like this. How many 7's in 9? There's 1, remainder 2. How many 7's in 24? There are 3, remainder 3. What we want the children to understand though is they're actually partitioning the 94 and splitting it into 70, 21 and 3. The first two numbers, of course, multiples of 7, and the final one, the remainder. Let's have a look at the final example. How many 6's in 3? Well, there are none, so I'll need to carry the 3. How many 6's in 32? Well, 6 5's are 30, and the difference between 30 and 32, of course, is 2. How many 6's in 21? 6 3's are 18, so it'll be 53, remainder 3. To deepen the children's understanding, rather than asking them to answer questions using larger numbers, we'll give them a range of different contexts. For example, this context question here, the children have to understand what they do with the remainder. They'll actually need to round up. This question here relies on their understanding. Do they see how many 1.5's are there in 6? Because if they try and do that using a standard method, of course they'll find it more difficult. And the final question again, an inverse. The next video looks at how division concepts are extended.